All right, for the last part of Unit 6 that we won't get to cover is to apply geometric concepts in modeling situations. So the first standard we want to talk about says to use geometric shapes, their measures and their properties to describe objects. Example, modeling a tree trunk or a human torso as a cylinder. So the key features are we want to be able to model everyday objects using three-dimensional shapes and describe the object using characteristics of the shape, visualize and identify the dimensions of the shapes that can model. And the shapes we're talking about are a rectangular prism, which looks like a box, a cylinder, a cone, and a pyramid. So those are the shapes that you want to be able to visualize and say what kind of everyday object is in which one of those types of shapes. So this example here says, this is a hand drawing of a mountain. Explain which geometric shape could be used to estimate the total amount of earth the mountain is made of. So you want to identify which 3D dimensional shape would best describe the shape of the mountain. And you're right, the best one would be the shape of a cone. That would give you your geometric shape. The second part of this is the next standard, which says to apply concepts of density based on area and volume in modeling situations. Example, persons per square mile, BTUs per square foot or cubic foot. And when they want us to solve real-world problems that can be modeled using density, area, volume concepts. So the example right here says, a construction company is preparing 10 acres of land for a new housing community. The land contains large rocks that need to be removed. A machine removes 10 rocks from 360 square feet of land. About how many rocks will need to be removed from the 10 acres of land? So it says, what we want to do is we want to figure it out. So what I kind of do is I kind of take my comparison where you have 1 acre and put that over 43,560 feet. All right. And I know that I've already, I know that I have 10 acres. So I'm going to put acres as my numerator. So I want to know how many square feet I have. So in order to do that, I'm going to cross multiply. So I'm going to multiply 1 acre times x. So x is going to equal that. And I'm going to multiply 43,560 times 10. So that's going to give me, I have 435,600 square feet. And I know that if I have 435,600 square feet, I can set up my proportion that I have 10 rocks for every 360 square feet. And I want to know how many rocks will be over 435,600 square feet. And to solve that, I will need to cross multiply and solve. So when I do that, I find my answer is I have 12,100 rocks. The next part of this standard is to apply geometric methods to solve design problems. Example, designing an object or structure to satisfy physical constraints or minimize cost, working with typographical grid systems based on ratios. So the key idea is to apply constraints to maximize or minimize the cost of a cardboard box used to package a product that represents a geometric figure. Apply volume relationships of cylinders, pyramids, cones, and spheres. So we just want to try to see which one of those and apply the volume formulas that we know. So here we have a company that needs to package a bale in a rectangular box so that we know that we want a box that will hold this bale. So we're trying to visualize the smallest dimensions, length, width, and height the rectangular box must have. So I know that if my diameter is 6, it's going to be the diameter 6 this way. So I know my length and my width both need to equal 6. So the bottom part of the bell will fit in the bottom part of the box. And I know that my box also needs to be 8 inches high so that the bell will fit in it that way. So I would say the smallest dimensions are 6 by 6 by 8. What would be the volume of this box? Okay, now I want you to see if you can work this one out. First of all, Joe counts 250 peaches on 25% of the land he owns. He determines there are 10 trees for every 1,000 square feet of land. About how many acres of land does Joe own? So if there's 250 peach trees on 25%, how many peach trees are on 100%? And then you can set up your formula and solve it. Same way on this one, answer this question. The space inside the box around the pyramid is filled with protective foam. About how many cubic inches of foam is needed to fill the space around the pyramid? Answer that one.